Okay, let's start. This is lab 11 for AgEcon 305. This is our last lab of the year, and we are going to continue working on price forecasting. And so, in class on Wednesday, I took you through some steps and basically ended with this graph showing a predicted set of prices, the actual prices, and then the error that I would have if I'd used these forecasts over time in predicting the real price. And so this is our method. So price forecasting is not automated. It is not something that just happens. It is sort of technical breakdown. Target one component, try to fix it, and then look and see what's left. And so at the end of this lab, that's one of your questions in the assignment. Look at this final prediction for prices compared to actual prices, the orange line versus the gray. And then based on what's left in the yellow, how would you go about trying to improve the prediction ability of this? Or is there something about these errors down here that make you think this is the best we could do? And then we'll talk about that again at the end after we've been through the steps. Okay, so when you first get a data set like this, there's not much to it. It's just somebody has recorded what they believe is a good average price for a month for each year and kept track of that. So this is the New York Harbor conventional gasoline regular spot price. That means there's actual spot price means it's traded at that spot, at that location. There's actual exchanges going on. And FOB means that that's the price as it sits there, not the price that you might pay in Indiana. So the Indiana price would have the transportation tacked on. So free on board means, or FOB means free on board. So this is something you'll see in prices a lot in the spot market measurement because it doesn't account for the fact that the true cost of that gasoline for the places that will sell it at retail will add on the transport cost. This data is sparse. There's a lot of work to do with it, and I don't want to cover that in the lab. I want us to focus on our technique, on this idea that we can break apart prices. We can start to think about what's happened over time and try to do a good job of forecasting. Just using simple tricks, or simple techniques, simple methods. Repeated regression to try to isolate different components, those kind of things. And so I talked you through all of this in the lecture on Wednesday, but let's just go through each of the columns that have been added. So we have the data that was given over here, year, month, and the New York Harbor FOB price. I did create a month and year label since for your graphs you may want to say 1987, what month in 1987, what month in 1988, etc. And you'll see here, I don't know if we've used this before, but that's just the concatenate function. It just says take the information, the text that was in B10, and then at the end of that text, add the text from cell A10. Okay, so that's a single formula called concatenate, and it just works on text. It just adds text together and takes, or if you've done a little bit of computer programming, they would call it a string. So a string of characters takes the string being held in this cell and then adds to the end of it, or concatenates it with the string of text there. And so this is the set of labels that I had for any of my graphs. The first sort of data column here is just the trend variable. So as we talked about on Wednesday, we just start with some values. We just start typing 1, 2, and 3, for instance, and then you can just drag all the way down, or you could make a formula that just says add 1 to the cell above it, however you want to do it, it's easy to put a string, or a sequential set of cells numbered in Excel like that, and that's all we need for a trend. Remember, all we need is for the variability to be driven by each successive period has one count higher in the trend variable. The second variable that I added is this 12-month moving average. Okay, and so that one's a little more, a little less intuitive. It is not an annual price. It is the most recent backwards and forwards 6 months prices used in an average. So one way to think about this would be, on July 1st, I want to calculate the 12-month average using 6 months of data that preceded it and 6 months of data that come after the 1st of July. And so that's what's being done here, is we take the 6 months before, and then we include the month itself plus the 5 months after. And so if you look at this cell, it is taking the average from C4 to C15. So it's using 12 individual prices to come up with an average that sort of surrounds or centers that price. Okay, and so that one, again, once you put the formula in correctly, then it just shifts down. And so when we move down one cell, instead of C4 to C15, it's now C5 to C16. And so those will all follow form. Okay, now we calculated that moving average price because we are actually after something different. We want to know something about what are the seasonal effects. Every time July comes around, we know there'll be something in the pattern of demand during the course of the year that could cause prices to be above or below sort of their natural expected level. Okay, if you took the annual price, it would be a blend of all the different demands that happen over the course of a year. Well, that's sort of what's being done here, except we are centering it around this current month to get that moving average. And so the seasonal effects then would be, what's the sort of central point or the basic average that you would see before and after that month, right? So the moving average part should account for any big cycle, any economic cycle effects that are going on in the most recent 6 months before and 6 months after. And what should be left in the moving average should be the sort of year-to-year sort of routine monthly effects from demand, right? So whatever demand is typically, it could spike up in July, August, September, October. And so that's what we're after. So we have all this list of moving averages here. And so what we're going to do for our seasonality guess, our point estimates, our series of seasonality estimates is make a new formula right here that just says take the actual price, subtract from that the moving average price, the sort of basic trending or moving along of the economy price, and what's the difference in that will be what we call the seasonal effect. Okay, so we're taking the actual price minus our moving average measure in each month, and what's left we're going to call this series of data, this column of data right here, the seasonality effect. Okay, and so that's a set of data that is really organized by month. Okay, so the comparison point for July 1987 of the S variable is July of 1988. So it was 0.04, then it was 0.06, and then if we kept going, we'd find another July where it was actually negative. Okay, and so everything that we're doing with this seasonality is doing this is our best way, or our best guess. I mean, there are lots of ways you can look at seasonality effects. But the approach taken here is to take this centered moving average. What have prices been like in the economy 6 months before, 6 months after? How different was the actual price in this month compared to sort of that generic movement of the economy? And then we'll use all those observations for July, all the ones for August, September, October, and compare them only to the same month year after year, and then we'll get our estimate for average seasonality effects. Okay, and that's where, there's my label, but that's where these 12 columns come into play. Okay, so we have all of these dummy variables. D1 is January, 2 is February, March, April, May. So if you track it on that diagonal, I guess only to here, you can see that you get a 1 for the month that is categorized by the dummy variable, and a 0 for all the other months. Okay, and so what that lets us do is run with a single regression and compare our column on seasonality. We'll use these dummy variables, and we'll end up actually getting the estimates for each month. We'll get the estimates. For each month, we'll get the estimates of the average seasonality effect. So over this, I don't know, 25 years of data or whatever it is, I guess it's 27 years of data, we'll have good approximations of sort of every time July rolls around, how much do we expect gas prices to bump up. And so let's run that regression. So if you remember, we go to data, and then we go to data analysis, and choose regression. Click OK. Now we need the Y range, and so for the Y range we're only using where we've calculated a value for S. So that means we start in row 10, I hit Control Shift, and then I hit the down arrow, and it goes to July of 2015, which is the last time that I can calculate S based on that moving average. And then we click the red arrow to bring back up what we have. Now for the X range, we need all the dummy variables in our data. Okay, and so I think it's set up, if we go all the way back to the top, where we can start by highlighting D1, the top corner, and then hold down the Shift key and move all the way across for D12. And then if you hit Control and the down arrow, I left off one, I put a blank right here so that it would stop, and you're only getting the matrix of dummy variable entries out here that match up with the places that we have an S measure. Okay, and so you see all these values for the S labels out here. Okay, click on that, and this time I want the results to end up in a new worksheet ply, okay, for the regression output. So we put these in the new worksheet ply, and that means it won't enter in, it won't show up in our data sheet here, and we click OK. And what else? There's one more thing I need to hit. Oh, this box right here. We have to click on this box because we're using 12 dummy variables. We have to click on this box and force the constant row to be 0. So the intercept, if you're going to use 12 dummy variables for 12 months or 12 categories, then you are not allowed to have, you're not allowed to use an intercept in your model. Okay, and so we are going to get rid of that by clicking on this and forcing the constant row, or that intercept row, to be 0. Everything else looks okay, so let's click OK and see what we get. Okay, and this probably okay, so I paused the recording to clean up this so we could look at it easier. And so what we see here are all of our estimates. This first row are the estimates for the dummy variables. So January, February, we get negative effects, March 0, and then starting in April through September, positive effects, and then they shift back to negative. Okay, so we've got 1, 2, 3, 4, 5, and maybe even 6 months where we see this sort of negative seasonality, and then 6 months of sort of positive seasonality. these are our best guesses. These are our best estimates of how much every time the month rolls around that we're talking about, prices either move up or down. We've done this in a linear fashion. We could have done it in a percentage change fashion, right? If you believe that the price spikes are not levels, not sort of a 5-cent bump, but they are in fact a 3% or 5% bump, we could have switched and tried that. So there are lots of options. Again, so even though we're doing this in one way, I want you to keep your mind open that there are all kinds of sort of modeling ideas that could be brought to bear to try to improve this. And again, when we get to the end, I'll talk about and encourage you to think about in the assignment questions. How could the forecast be improved? How could we have made it fit better to the historical data? And is that enough to give us the belief that we are doing a better job of predicting the future by tracking the past more accurately? Okay, so you can see here the t-stats. This t-stat is negative. The only way for that to be negative is if that coefficient is truly a little bit below 0. But the interesting part of this, and I may have talked about it in class on Wednesday, is that you end up with this coefficient that's not significant. Well, sorry, let's go to the p-values. This coefficient is not significant for March, and this coefficient for October is also not significant. And what's notable about that is there definitely seems to be a seasonal pattern. Okay, so we end up with these negative effects here and here that are significantly different from 0 based on a p-value that's below 0.05. But when we get to these transition months, March and October, the effect is not significantly different from 0. Okay, and so that's this sort of noisy period between when prices tend to stay higher, the sort of monthly effects tend to be positive, and then they're going to shift and the monthly effects are going to become negative, and we end up with this sort of noisy month of time where prices are adjusting, and so sometimes it's enough, sometimes it's above, sometimes it's below, right? So that extended period of higher prices during the middle of the year, during the summer months, may be extended, and that's what's causing the sort of insignificant effects here and here. Okay, so in general, we have a bunch of effects that we believe in. They all pass our tests for significance, and so the only thing left to do is take these 12 values and bring them back into our forecast process. And so the S adjustment, this column right here, is what I've done, and I've given that to you so that you don't have to paste all those in, is the adjustment for each month. And so you'll see it's repeated every 12 months. The pattern recycles, and we end up with this column right here, the seasonal adjustment. We use that seasonal adjustment. We only use this column, this average effect, to go back to our prices, and we are going to do something here. We're going to calculate a seasonal adjusted price. Okay, and so this column is the season adjusted price, if you don't remember what that was for. So SAP, seasonal adjusted price in each period. So the seasonal adjusted price July 98 of 87 is 49 cents, 45, 46, 55, 58, 58. So we're making all these adjustments, and for every time period. So it gets copied, the average effect gets copied over and over, and that becomes the data that we're going to use to estimate our new trend. Okay, and so we have taken out the monthly effects so that they can't affect our trend. The average monthly effect will not be part of the trend that we're going to produce, the trend estimates that we're going to produce here. We are going to get effects that only depend on what does the trend look like after the seasonal effects have been taken out of the prices. Okay, so that means this is going to be our regression price. We're going to regress the seasonally adjusted price against the trend variable, and then we're going to need to know what the predictions are for all of those. Okay, so let's go through that step, and that'll be the last thing we do in lab, and then I'll direct you to the questions that you're going to have to answer in the assignment. Okay, so to do a regression here, we just go back to data. We go to data analysis, and regression's already clicked. We'll have to cancel out the data that's chosen. So Excel expects to do one regression per sheet, evidently. And so for the Y range, the thing that we're going to try to explain, we're going to highlight all the cells where we have the seasonally adjusted price. So in your data, in your version of this data sheet, this should already be calculated out here for you. So this is the first thing that you have to do on your own here. So we click all the way through there, and we have, sorry, let me do that. Let me show you what I did. So I started this, and I clicked on Shift, and then I held down Control and hit the down arrow, and that highlighted the entire row that has been filled in for the seasonally adjusted price. To get the X range, we only need the trend variable. There's nothing wrong with starting the trend at number 7, and that matches up in our columns. And so I think what I'll do is, instead of trying to highlight all the data, I'll just hit OK. And you can see that it goes from U10 to U346, and so I'm just going to make it go from D10 to D346. Okay? And that should be good enough for what we have here. So that should give us the correct number of observations, because you need one observation on the trend. You need one value of the trend variable to match up with each price. We don't need the constant as 0 now. We want the intercept in, so we click that to turn it off. We are going to put the output in a new worksheet. We want that regression to show up as its own in its own sheet. And then we want one more thing. Sorry. Yeah, we want the residuals. Okay, so the residuals are the point-by-point prediction values that that come from the estimation. So everywhere that you every point that you regress against will have some error component, and that's called the residuals, and that's what we're going to print as part of our, or we're going to have output as part of our new worksheet that we use. So let's we have U10, U346 over here, D10, D346 over here in the trend column. No constant, new worksheet apply, and check yes that we want the residuals. Click OK, and this is what we have. Okay, I cleaned up my regression sheet a little bit here so we could look at it. Well, not as much as I should have. Okay, so we end up with a couple of coefficients here, some negative intercept, some positive trend amount. And again, even though we are primarily focused on generating a forecast, right? So this trend isn't something we are going to spend a lot of time on in the regression components. We should look and see that it passes sort of basic statistical functionality. And so we're getting a positive trend, which seems to match our data. It's got a very large t-statistic, a very small p-value. The r-squared is 73.73, so that's pretty good. So it's getting 73% of the variability in the seasonal adjusted price is being accounted for. That leaves quite a bit, and the pattern of how the errors show up might be something that's important to us. But anyway, so we got our estimates here, and so now the trick is to go back in and put together our predicted trend values. Okay, so how do we predict the trend effects enter into this model? And to do that, that's why we asked for the residual output. It's because as part of the residual output, you end up with the predicted values for y. Okay, and so we'll get all of this data here down at the bottom, and the residual output tells us what the predictions are from just the seasonally adjusted trend model. Okay, so if we hit Shift, Control, and down arrow, you can just copy all of that, Control C, go back to the data sheet, and then match it up against the seasonally adjusted price and hit Control V. Okay, and so now we have our trend forecast. SAP trend forecast prices. Okay, so SAP actual, SAP trend values. Okay, and so you start to see some of what's going on here. Look how this starts negative and very small, and it's only later in the data that it starts to catch up. And so that's always a sign that there's something going on, that your straight line trend approach doesn't have good fit with what's in the data. These are values that are not allowed to exist for prices. But they might exist for seasonally adjusted prices because there is a calculation that we've done. So what do we do to get back to our forecast actual price? Well, we take our trend forecast for the seasonally adjusted price and add back the average trend effect. Okay? And that's this part. So we are just going to take the value in V10 and add that to the value in T10. Okay, and so we got a 5-cent predicted price, which is not good. Right? We're still well below actual there. So we're getting a lot of error in the early part of our forecast, and that's something I'll talk about when we actually, when I show you the plot at the end. Okay, so we get the forecast actual price. We need to fill in all of those, so copy and paste that formula for everywhere that we have a trend forecast, and you'll end up here. Okay, so you see a lot of better predictions, a lot of better predictions towards the end here. Our forecast prices against actual. So here we have 215 versus 190, 203, 231. Okay, so it seems like we are under predicting in a large swath of the data here. Okay, so we have that, and this becomes our true sort of forecast, our best forecast that accounts for both seasonality and trend. The moving average part here was part of the seasonality calculation that we did. We could actually implement that as well as one method of trying to add another sort of regression or prediction piece to this to try to fix some of this error that we have. There's some other things that we could talk about. The lags that we had. Of course, at the end of lecture on Wednesday, I talked about the lag and moving average as ways to try to train the prediction or the forecast model, to try to train it to look at what's been going on in the most recent months or in the most recent sort of 12 months with a moving average, so that it balances out sort of the long run trend against sort of the nearby trends, and of course adding in seasonality. Okay, so if we just plotted all this here at the end, then we would be able to look at what we've got. Okay, so yeah, sorry, I wanted to check something there. So the last thing that I want to do here, and then I'll leave you to the assignment paper, is we're going to plot this, and then you can add other plots to it as you want, or as you're directed by the assignment. But we have used, historically in this class, we have used XY scatter plots. And this is one time when we are using time on the horizontal axis. We're plotting all these things against time, and we know that the time periods move forward at a constant unit. And so we're going to be able to use a different kind of graph that'll make it a little easier to look at this. So pick a cell somewhere over here to initiate your to be sure that the data is not being auto picked up by Excel, and go to Insert, and then for our graph we're going to choose a line chart, and then just choose the basic 2D line chart right here. So the first option is the simplest. Now when we select data, right, so we if you have another preferred way of doing this, maybe highlighting the data that you want to graph beforehand is the best way, but I always try to produce a blank graph and then select the data myself. So select the data, and then we're going to add, and so the first thing we're going to put in is the forecast price, and then for the series values, just come out here and get the prices, all the prices that we just calculated using the seasonality effect plus the trend forecast. Okay, and so we have the first one there. I'm going to shift control down arrow to get all the values. Hit OK, and then for the labels, then we need to, they're currently the labels that would show up on the horizontal axis are 1, 2, 3, 4, and 5. Well, we have that month and year label column over here, so we could change this to use those labels. So let's go over here to July 1987. That's the first one we have. Hit Shift Control down arrow, and it'll highlight the entire column, and hit OK. And so those labels 1, 2, 3, 4, and 5 get replaced by those monthly labels that I put in the spreadsheet for you. And there you have the graph of our forecast price. So we get monthly effects, right? So it shifts down, right, in October, November, or passes through 0, I guess is the right way to say it. So it gets about 0 in October, and it gets about 0 in March. Then it moves down to a negative couple months, right, down in here, and then it moves back up into sort of the positive part. And so there's a trend line going through here that's a straight version of the line. Sometimes it's above trend, sometimes it's below trend. And then because we have a linear trend, these things tend to follow a linear pattern moving upward. That's our forecast price. If you hit Select Data and click on Add, you could add the true price measures, and if you want to reproduce the actual graph, you would need to calculate the price error. Okay, so take the forecast price out here, the forecast error. Okay. So there's always however you do it, you either want to subtract the actual price from the forecast price. In those cases, negative values means that you are under predicting, and that's what I like to do. So I'll take the forecast price, subtract from that the observed price. So a negative value here means I'm under predicting the price, and then you can copy that all the way down. You could you could add to this sheet here your forecast errors. Okay. Sorry, I'm not sure what I just did there. So either way you want to do it, either positive or negative. The key is being sure you understand how you calculated the error, the difference between the forecast and the actual, and being sure that you can look for the pattern. Because let's go back to the PowerPoint. I may have changed the way I've done it here. Yeah, so okay. Since you're probably going to want to match this. Change this and to make it be the true price minus the forecast. W10. Okay, and that'll match what was in the lecture slides. Okay, so here in this, when the errors are positive, it means I'm under predicting. Okay, so positive means we are lowballing with our forecast model. When it goes negative, we're over predicting. Okay, and so this minus this will be negative. And that's really what we're looking to do here. So what I'm going to, when you think about the assignment or think about going through this, you are asked to reproduce this graph and then also produce one that only looks at a straight line trend through the real price and look at those errors. Yeah, and so, sorry, I keep forgetting here. So what's important though? At every step when we come up with a forecast model, when we put this forecast together and check it against actual, is there something left down here that makes us think we could improve this? Is there some pattern, right? So the idea is in the error that's left down here in the yellow, this is the most important piece. In the errors that are left, is there some pattern that we might be able to identify and improve the actual forecast? Okay, is there something about this? And so one of the things I talked about in class and what I think you might find interesting to talk about in the last question on your assignment is, did something happen? Right? So look from July 1987 to September of maybe July 2002, something like that, that caused prices to trend only a little bit upward then, and then to really take off. Is there a regime change or a structural change in gasoline prices that happened? And so that could be something as simple as breaking apart the data and doing a trend here and doing a trend here, something like that. But anyway, so we've been through the steps. You asked to make this graph, in which we've already done the first part of it. You just need to add a couple of lines to it. Make this graph or something like it for your assignment, and then also go back into the data. Let me bring the data back. Go back into the data and do a regression that says that regresses this price against just the trend variable. So the true price in this column, how well is it explained by the trend variable, and see if you see something that's similar to, how improved are things by doing this seasonality adjustment? How much improvement is there? Can you detect any at all? And that's sort of the comparison point that we'll make, plus the idea. The last question in your assignment will ask you to think about where you might go next. How might you deal with that? So we've talked about lags a little bit in class and what kind of effect that might have. And then the other thing I've talked about here is trying to break apart the time series and say, is there some sort of structural break, some sort of dummy variable that we might put in the first 20 years of the data and test it against that. I don't care so much that you actually implement that, but I do want you to be thinking about those kind of things and sort of propose what your next step might be, and what you expect the effect might be. And if you want to play it out and you have difficulty implementing your own idea, then let me know, and I will certainly help you with that. But we only have limited time left in the semester, and I don't want people to feel bogged down trying to get this one piece of an assignment that actually counts towards your final exam done. So really just discussion and ideas, maybe as far as it can go, but it doesn't have to stop there. If you want to query me and get a little extra help pushing your idea forward. Okay, so I'm gonna cut the video off here and let it start rendering, and I'll look forward to seeing your applications for this exercise.